Greetings everyone, we are the Basai Grizzlies and we're here to teach you guys about the function and the purpose of HTTP by reenacting a basketball game. The group consists of 5 members, Warapon, Gongpop, Chinagrit, Gritapat and Charn. We'll first start off with me, Charn. I'll be explaining the HTTP description and client-server architecture.
I'm Warapon, and I'll be responsible for the HTTP method and examples, which include get, post, delete, patch, and the corresponding response code.
Then I'm Chinagrit. I will be in charge of the HTTP response code 100 to 500.
I'm Gongpop. I'm the guru of the non-persistent and persistent connection.
And lastly, I'm TT. I'm gonna be covering statelessness and cookies. Yum!
Oatmeal cookie, it means whole lot to me.
Hypertext Transfer Protocol, otherwise known as HTTP, is a standard for any data exchange between the client and the server. In this case, the client is the browser making a request to the server, which the server helps grant the request and deliver it back to the client. This magnificent creation was developed by Tim Berners-Lee at CERN in 1989, and we now often see it whenever we go surfing on the internet. In order to understand the HTTP methods, it's important to cover the concept of client-server architecture. This architecture describes how all web applications work and defines the rule for how they communicate.
Take this following scenario as an example of having no standard HTTP protocol.
Can
you guys all just speak English or something so everybody can understand? Without the standard HTTP protocol, it is like playing basketball with different languages, which will cause confusion among your teammates.
Now, of course, other than the language, there is the grammar, or how you actually structure the message. In this case, a client is making its request in a non-standardized grammar format, and the server has a difficult time understanding the request. Some of the most commonly used methods such as get, put, post, delete, and patch are displayed here on the screen. A proper HTTP request always begins with a request line, which includes a HTTP method, then the body of the request. Then the server responds with a HTTP response, first starting with the response code, then adjacent body.
A few moments later.
The type of response code in HTTP vary based on its first value. With 3 digits, the first value, which will range from 1 to 5, will classify into each of their own category, and the last 2 digits will help identify the response in the category. Here are some of the examples.
For code 200, or as known as OK, this means that the package, which in this case is a basketball, got transferred to the server, and the request is fulfilled and sent back to the user without any issue. Next up is code 404, the infamous error not found. In this case, when the package got sent, the server cannot find the requested resource. And for code 418, when the packet is sent, the server refused the attempt to brew the coffee with a teapot. Code 500, or as known as internal server error, the server has encountered a situation it doesn't know how to handle. And here is a list of all other HTTP code, which you can find online.
Perfection.
In HTTP, there are 2 main types of connections. For a clearer picture, let's see them in action. For a non-persistent connection, the client must first establish a connection with the server to be able to send a request for the data that they want. As depicted in this scene, the client needs to get the attention of the server every time they wish to request for an object. For the persistent connection, the client is able to maintain the connection with the server. In this case, the connection trip will only be used once, as after requesting for something, the server will wait and listen to the client until the client ends the connection. Both connections have their pros and cons. The non-persistent connection is automatically closed, meaning it decreases the CPU and memory usage on the server since there's a lesser number of connections to listen for at a time. The persistent connection, on the other hand, is able to take the advantage of transporting as many things as you want over a single connection and reduces overheads.
A cookie is used for recognizing the client's activity by creating an ID and backend database. This improves your browsing experience by storing small data upon the server you're connected to, so that next time you access it, it knows the information to specifically serve for you. For example, you don't have to re-log into the website again after the first access without cookies. You have to restart everything again, like relogging a website every time you visit it, which can be very annoying.
Imagine you're discussing the game plan with your coach. in this case the server, suddenly there's a blackout and the server forgets the user identity without having cookies. Who are you guys?
For the second scene, cookies are applied, which in this case is a roster. The blackout still represents the close tab or exit. Then once the light comes back and the code is changed, the coach looks at the roster and remembers the ID, which is the position. The games continue.
Throughout this video, we've learned what is HTTP, how is HTTP response and request formatted, what are the common HTTP response codes, what are persistent and non-persistent connections, and how to keep state using cookies, all through the demonstration of basketball-related short skits. We hope this make the concepts of HTTP easier to understand for you. And don't forget to hit the like and subscribe button.